This is Mark Kemper with EMS, and in this video, we're going to compare some different 3D scanning and inspection technologies for different applications and uses. All right, to get started, let's talk about what we're trying to accomplish in this video. Now, this video is not about any specific brand or model. It's really more about the type of technology versus a specific brand name and specific model. And this is really around the commercial, professional grade of equipment. There's certainly consumer and prosumer equipment out there, and we're really talking about the commercial market. So there may be differences in those other markets. So we're going to focus on the professional grade systems. And we're going to, if you want to learn more about any of these technologies, we have some great YouTube videos that go into in-depth demos. There's other great videos out there from other folks as well. Go check those out. I'll put some links in the description below, and you can see some in-depth demos, and that's really going to get into more about how these systems work. We're not going to cover that. We're really talking about the applications and the pros and cons of each type of equipment. So to get started, let's just do a general overview of the 4 technologies we have here. And again, we're not going to go into a lot of detail, but I'll just do a brief overview so you understand what we have and then what I'm calling these technologies in this video. So over here we have a tripod mounted system. This is typically a structured light system. It has a projector and a lens or a sensor, and these are typically interchangeable so that you can put in different fields of view, different size fields of view. Typically this will mount on a tripod or a large measurement stand, and usually if you're in a lab, a measurement stand goes up and down and in and out, just gives you a lot of flexibility. And oftentimes they are used with an automatic rotary turntable, especially if you're doing smaller parts. You can put them on the table and the system can scan it. Now if you're doing something larger, that's where you're going to have to move that system around. But we're going to call this our tripod mounted system for this video. Next up, we have an optical system, okay? And the way an optical system works is this is the scan head. You've got lasers and cameras on here. And then, off in the distance, you're going to have another set of cameras, usually larger, that will track this in space as it moves around. So that separate camera system tracks this system, and then there's another set of cameras on here and lasers. When you're actually doing the laser scanning, it's picking up the shape. So this will do both 3D scanning and it'll do probing. And probing is just going and clicking one point at a time. So that is what we're calling our optical system here. So it's optically tracked for scanning and probing. And then over here we have a handheld scanner. Pretty self-explanatory. You hold it in your hand. There's no other equipment needed other than, of course, a computer to 3D scan. These can be laser-based. They can be structure light-based. They can use targets, positioning targets, and some of them just use geometry to align as you're moving. And I should point out, this system and this system, you're continuously moving while you're scanning, where this system, nothing can move while you're scanning. While it's acquiring the data, everything has to be still. And then last over here, we have an arm-based system. This typically mounts on a tripod like you see here, and this arm articulates out and allows you to probe and scan. So this one has a probe and a laser scanner on it, and you basically pull the trigger, move around and scan, or you drop, pick points as you go along. So this is also continuous scanning while you're scanning, and then obviously when you're probing points, you're holding it still. So this is what we call an arm-based system. So that's kind of the definition for this. And what we're going to do next is talk about really different applications and really pros and cons for different categories. What are the strengths and weaknesses of all of these systems? Okay, so the first thing we're going to look at is setup, because all of these systems have to be set up to be used. Okay? Now, if you set them up once and leave them in your shop and don't move around, obviously setup's not a huge deal. But if you're moving around in your facility from one place to another, or you've got a facility down the street, or you go out to customer sites, setup is a far bigger deal. So starting over here, obviously we've got a tripod we've got to set up. We have the unit itself, and there's some plugs that plug into the computer. We don't have those here, obviously. We have to select our lenses, and they just thread in. You put the proper lenses in, and then you'll have to calibrate it. And there's a series of different size plates. Depending on what lenses you're using, you'll set that plate up, and you'll take 10, 12, 15 scans at different angles. It walks you through. Typically, all of these systems really require some warm-up. Not quite all of them, but most of them do, or acclimate to temperature. I'll get to that in a minute. But you basically, all of these really want a steady temperature, right? You don't want to be measuring, especially if you're doing inspection, you don't want to be measuring starting at, 50 degrees Fahrenheit, and by the afternoon it's 75 degrees Fahrenheit, you're going to get thermal expansion. So you always want to let them acclimate to temperature, then calibrate, but if temperature changes a lot, you may have to recalibrate. So all of them have a calibration process. We'll talk more. But setting this up is really tripod, plugging everything in, plugging in the rotary, picking your lenses, doing your calibration. As far as the optical system here, it's similar. You're going to calibrate the C-track. Basically, it's an artifact you hold, you move it around, you calibrate that's the camera system that you don't see here that would sit off in the distance. And then you're also going to calibrate the head and the tripod, or sorry, the probe. And of course, you've got to plug everything in. The camera system usually would sit on a tripod or a measurement stand. So a little bit of setup there as well. And then the hand scanner is probably the easiest to set up. You take it out of the case. There's usually a calibration plate. It's usually maybe a minute or less to calibrate, and you plug into a computer and off you go. With an ARM-based system, obviously you've either got to have a big tripod like this, or you've got to have a pretty heavy-duty measurement table. Typically, you'll see they're made out of granite, and also this is somewhat of a portable tripod. There are some really heavy-duty ones. If you're keeping it in your shop, you set it all up, you plug it in. Also, you do some calibration of both the laser and then the probe. So all of them have a bit of a setup to them. Certainly the handheld scanners are by far the easiest as far as setup. They're just so easy. You pull it out and you calibrate it. The rest of them, you could argue, they're all about the same as far as setup. There's a little bit more to it, more things to plug in, more things to calibrate. One isn't necessarily easier than the other, just they have more to them than typically a handheld scanner. All right, now let's discuss part size. So depending on what you do, you may scan all small parts, you may scan all large parts, you may scan just maybe medium-sized parts, and other people scan all kinds of stuff. So which ones of these systems are good for what types of parts as far as size? So let's start with small parts. If you're doing small stuff, when I mean small, I mean really tiny stuff, by far the best technologies out there are these structured light systems. And the reason being is you can put in these interchangeable lenses and you can get point spacing down to like 10, 12 microns. It's absolutely amazing the level of resolution you can get out of these systems because of these interchangeable lenses. So this particular one has a lens that is a field of view of 45 millimeters, and this is 5 megapixels. Now some of these systems go up to 10, 12, 16 megapixels. So imagine the points. So it's the same megapixels, you're just looking at it through a smaller and smaller lens, just like in photography. And then these can go as wide as 8, 1,000, 1,200 millimeter lenses so that they can do bigger stuff. But if you're talking about really small, like really tiny precision, dental little appliances or surgical tools or just really small stuff, these structured light systems are the best systems out there for that kind of stuff. Now, when you start to get into things a little bit bigger, most of these systems are pretty good. Typically, these handheld devices will go down to about 100 microns, and even some of the newer ARM-based systems can get down to that. So if you're getting into things that are more kind of, a few inches in size and bigger, then really all of them will work. But if they're small and they have fine detail, The tripod mounted systems will be the clear winner. Plus you can mount it on this tripod and it'll automatically rotate around. The only thing that's going to get better is an industrial CT scanning system, but those are very expensive and they have challenges to them. But again, for very small stuff, this is great. For once you start getting into a little bit bigger, they'll all work pretty good. Now let's talk about maybe medium size. Let's call medium, 3 to 6 feet in size. Big machine parts, plastic injection molders. Think of like a bumper on a car, something like that. All of these will certainly work for parts like that. Now there's little differences between them. These types of systems typically require targets. Again, I mentioned some of them don't need targets, but depending on the geometry and stuff, you're going to put some targets on it and you're going to scan it, and that's going to be fine. This system doesn't require any targets because it has that camera system. It's going to work just great on medium stuff. This, you're going to have to go to a bigger lens. Then you're going to have to, take overlapping scans and move around. So it can be done, but when you start to get to bigger stuff, the tripod mounted starts to become more of a challenge. I'll get into more of that too when we talk about large stuff. And then ARM-based systems, it's really what can you reach, right? So, there's different length arms out there, right? And, you can get some that have up to a 12-foot reach. Now, keep in mind, that's 6 foot in each direction, so you got to be able to put this where you can kind of reach everything. But in a single setup, they can handle a medium-sized part without too much difficulty. Now let's talk about larger parts. So now I'm talking 8, 10, 12, 15, 20 feet, big industrial castings, big aerospace structures, things like that. Well, that starts to become a challenge for these systems. Even though you can get a wide field of view, like I mentioned, 800, 1,000 millimeters, it's a pretty big viewing area. The problem is when you start doing that, because you're taking a single shot and moving along, to get any accuracy, you have to introduce photogrammetry. Now, I'm not going to get into a lot of it there, but that's a camera system and scale bars, and you got to target it, and then you have to put coded targets, C-O-D-E, like a code, not coat like C-O-A-T. You have to put these targets that have basically symbols on them. You got to you have to take all the photos, you have to process that, and then you start scanning. So when you get into larger stuff, this system is going to be a challenge. It's not that it can't be done, and it's not that it can't be done accurately, but it's going to take more time because of the setup and the photogrammetry. Now, when you get into large stuff with an optical system, it's the clear winner. Because of the way these optical systems work and they have this big field of view, you can scan very large stuff in minimal setup, and you can do it very quick. We'll get into speed in a separate subject here. But optical systems for large stuff work very well. The handhelds work pretty good. Typically, again, you're going to be targeting, because if you don't target and you're doing something large, you're going to lose accuracy quickly, okay? So you have to target. Now, targeting isn't always the funnest thing in the world to do. There are some tips and tricks and techniques we show in some of our videos, and then there's things like magnetic targets, and then there's now our new speed target tape, which is basically targets on clear mylar tape that you can put out. That really speeds up the targeting, not only putting them on, but even faster to remove them. So there are ways you can do it. So with a handheld system, you can scan a part 15, 18 feet long. It's just there's more setup with targeting. Now, when you get to ARM-based systems, there's also a challenge there, because the base can't move while you're scanning, and the object can't move while you're scanning, where with these two systems, they both can move, okay? And again, I'm not going to get too much into it. That's what those videos are for. But ARM-based systems, everything has to be still, and then the problem is you run out of room, right? You can only go so far. Well, then you got to move the base, and it's a process called leapfrogging, where you'll have an artifact. So you'll scan, you'll measure that artifact, then you'll move the base, you'll measure it again to keep scanning. The problem is you start leapfrogging around something that's large, and not only is it slow, but you start losing accuracy. And we'll talk about accuracy more later. Now, as far as the scan speed, some of these newer ARM-based systems, the laser systems, they've got interchangeable heads now. They have a wider stripe. They can scan fairly quick, but the leapfrogging really starts to become the issue. okay? So that's a little bit on size. So just to wrap up the whole size thing here, if you're doing really small, intricate parts, this is a clear winner. If you're doing anything bigger than that, a few inches in size to a few feet, these will all work for you. When you get into the medium-sized parts, you're really starting leaning more over here. And when you get into large stuff, the optical systems are the clear winner. And the others can do it, but they're going to take longer, and they have more setup to do it. So if you look at what you do, you know, as far as size of parts, that's really something to think about. Which system is the right system based on size of parts? Now, if you do a wide range of parts, you know, that's another challenge you have to think about. In a perfect world, you'd have one system that does everything, just like most things in life. You know, certain products are better, or certain technologies are better at some things than others. So that's a little bit about size of objects. All right, how about portability? Now, portability is important to some people, and other people it's not really a big deal. So if you do all your scanning in a lab or inspection in a lab, and your equipment never leaves that lab, it probably doesn't matter which one you pick here, because they're not going anywhere, right? Now, if you often take your stuff out on the shop floor, that starts to become a factor. And then certainly if you travel with your equipment, that's going to be the biggest factor, okay? So hands down, it's pretty easy to pick which one of these is the most portable, and that's a handheld. There's literally one small case for this thing. Obviously, you're going to have a laptop with you, but that's usually about it. The smaller cases for these, you can carry right onto an airplane and put in the overhead, and off you go. So if you've got an emergency and you've got to get out somewhere to one of your customers and scan or inspect something, nothing is more portable than a handheld system like this. The rest of these systems, it's a little bit more of a challenge. Let's start over here with the tripod mounted system. Obviously, you need a tripod, and depending on how high up you've got to go and what you're doing, you can get different size tripods, but this can be expensive equipment, and you want a good tripod, and typically good tripods are heavy and bigger. So you've got a tripod, we've got a gear head on here. Obviously, if we need the rotary table, we've got a Pelican case for that, we've got a Pelican case for this, and then of course you're going to have your laptop. And you may bring some other, you need your calibration plates, depending on the size lens. Those plates can get quite large. The smaller plates are about this big, but the large plates for those large field of views are big. So you've got to carry those with you. If you're taking your photogrammetry system, those have scale bars. They've got all the targets. You've got a lot of stuff. So these systems can be significant to go out, into the field with that system. The system here, the optical system, it's two cases, one for the optical cameras, and then another case for the scan head and the probe and different accessories. Not too bad, but certainly bigger than this, not quite as bad as this, but it's definitely more planning. If you're going, if you can put it in your car, it's one thing. If you're having to fly somewhere, you're either going to have to check it or you're going to ship it ahead of time. We typically ship our equipment ahead of time as opposed to checking it at the airport. We just have less problems if we ship it. And probably the hardest one to travel with is an ARM-based system. You've got to have a pretty sturdy base like this. Then you've got the ARM itself and all the accessories that go with it. And it can be a large case. It's sometimes difficult to ship because of the size of it. So I would say the biggest challenge is any kind of ARM-based system when it comes to travel. Again, if you're getting in your car and going somewhere, it's not too bad. But if you're having to fly somewhere, it's definitely more of a challenge. So again, going back to this, handheld obviously is the easiest one to travel with. Probably this one next, this one, and then this one. So if portability is a big deal to you, now of course you got to factor in all these other things like part size and different things, but just looking at portability, handhelds are the way to go. All right, next up, let's talk about speed. In today's world, everybody wants everything faster, everything wants everything right now, immediate gratification. So, and speed is money, right? The faster you can scan something, the faster you can get on to inspecting, reverse engineering, analysis, whatever you're doing. So what technologies are faster than others? Well, again, it gets into part size a little bit, but we'll talk in general terms. These have the interchangeable lenses, so on parts that are, not too large, you can get that big field of view. If you have a big enough rotary table, you can plop it down, tell it to take 10 scans at 36 degrees, flip the part, do it again. It can be relatively fast. Where this type of system slows down is if you have a lot of features and details, because again, nothing is moving while it's scanning. So even in the rotary table, depending on how many scans you take, you still have to go back and manually take some scans. But on a general part, of a medium size, this or even a small part, it's not bad. The optical systems are by far the fastest systems out there. And the bigger the parts get, the faster this gets. So this particular model has 30 laser lines, okay? This model has a single laser line. Do the math. This one has 22 laser lines. So it's significantly faster just because of how much data it can collect because it's using so many laser lines. Now, this has those bigger field of views, and it's a fringe pattern that shifts, so it can also collect quite a bit of data quickly. But hands down, if speed is the most important thing to you, the optical systems are going to be the clear winner. The hand scanners are pretty darn fast too, but obviously you have to target first. The ARM-based systems, most of them are a single laser line. Yes, some of the newer ones are larger, and they definitely are faster. But again, you've got that constraint of what can you reach in a single setup, and then of course leapfrogging around to get around something. So as things get bigger, this is by far the winner. I would say, with the handhelds pretty close behind. As the parts get smaller in size, again, something you could throw on this table, they're all pretty fast. If you're comparing, new current technology, they're pretty good. But again, if things get bigger, there's going to be a big difference in some of these technologies just because they can collect more data, they have more freedom to move around. This one has the least amount of setup. This one, once it's targeted, is pretty darn fast as well. So that's a little bit on speed. Hopefully that gives you an idea, depending on, again, what your needs are. All right, how about surface finish? Now, depending on what you do, surface finish can be a big deal. If you're scanning flat white or flat gray parts all the time, it's not a big deal. But if you're doing machined aluminum, carbon fiber, chrome, really shiny, dark metallic paints, things like that, that can be a challenge. So if you look at these different technologies, which ones are good or bad at those challenging surfaces? Well, I would say the structured light systems have the biggest challenge. Whether it's tripod mounted or handheld, structured light systems can struggle with some of these challenging surface types. And if it's outside bright sunlight, it just makes it worse. Now, there are the scanning sprays out there, the developer like Magnaflux, you spray it on, and then there's these new disappearing sprays where you spray it on and it basically sublimates or evaporates out over time. And, that will definitely help, but, it's another process. And with like Magnaflux, you have to put all the targets on first, you have to spray it, you have to wipe the targets off so the scanner can see it, you got to scan it, you got to wipe it all off. The disappearing spray works better and you can put targets over the top, but both of these are flammable. You can't fly with it. You've got to ship it ground ahead of time or arrange to pick it up or buy it while you're there. So it has its challenges. The other thing with the disappearing sprays, if you're doing it outside, it's really hot. They have an evaporation time. We find that drops significantly, almost to the point if you're doing something big, it's difficult because it just all evaporates before you get anything done. And again, it's just another process you're going to have to do. So structured light systems definitely have the most challenge just because of the way they're designed and how they work. Now, when you get into the laser systems, especially today's, most of these systems are blue laser, and they do a much better job. When you look at the optical system that have the most powerful lasers, they can scan just about everything. Shiny, dark metallic, chrome, machine parts, you name it. It's rare we have to spray anything, and it's typically just for like translucent parts where it's glass or clear plastic. Really is the only time we use scanning sprays with this. And even with the handheld, for the most part, works pretty good. All the new ARM-based systems that are blue light, they all work good. In general, laser is going to work much better. on challenging surface types than structured light. So if you're going to do a lot of those challenging surface types, laser's definitely the way to go. Obviously, there's other factors in there, but if not, you're going to have to do some kind of surface treatment for a lot of parts that are of a challenge with these structured light systems. Okay, now let's talk about accuracy. Now, accuracy is always asked, and it's always a hard question to answer because there's so many variables in it. But let me try to explain at least my thoughts on accuracy with some of these different technologies. Because again, there's so many things that play into accuracy. On paper, all these systems are accurate, okay? But it's always the details that matter, right? Are we scanning a small part? Are we scanning a large part? Are we out on a shop floor with no, air conditioning or climate control? Are we in an environment where things are moving around? You're trying to inspect next to a stamping machine. All these variables. Are we having to move the equipment? Is it very large? Is it small? Is it really, the surface really dark and shiny? All these things play into accuracy. Now, and accuracy is even a hard question to get an answer from some of the manufacturers because it all depends on what standard they're measuring to. They can quote any accuracy they want, and if you watch some of my our accuracy tests, are we inspecting a 4-inch gauge block, or are we doing a ball bar, at a much larger size, and are we doing it in a full volumetric measurement, right? So just that alone, how is any manufacturer measuring their equipment to what standard? So you need to look into that. Now, there are a few ISO standards. There's a VDI, VDE standard. We're not going to get into the weeds on that, but definitely check those out and understand how that standard is set up and how they're measured. But on paper, they're all accurate. So what plays into that? Well, part size and environment and user are probably some of the biggest things. So let's start with small parts. On small parts, these things are all accurate. I would say the tripod mounted systems on really small intricate stuff can probably be the most accurate. But the rest of these are all pretty accurate. And again, if you're using good techniques, talking about the user, proper setup, they can all be pretty accurate, okay? And again, I'm not getting into specifics, but they can all be used for inspection. Now, when you start getting into challenging environments and larger sizes, that's where we'll start to separate these. So on very large stuff, the most accurate system would probably be this system here, the optical system, or maybe one of the tripod systems with photogrammetry. Okay, they're both going to be really, pretty accurate. It starts to get really, really big, over 20 feet. These become a challenge. Then you're looking at laser trackers and other technologies. But these work good. The challenge, as I mentioned, with ARM-based systems is leapfrogging around something. You're just introducing accuracy every single time. The challenge with a handheld system is the farther you move away from where you start scanning, you're stacking up that inaccuracy. Now, these systems will work with photogrammetry, and there's add-on photogrammetry systems, so you can definitely control that just like you do here. This one pretty much has to have photogrammetry to work on larger stuff. These don't, but they will be more accurate over distance if you use it. And with an ARM-based system, there isn't really photogrammetry. Now, some of these newer systems will tie in with a laser tracker, and that'll help their accuracy. But, it does become a challenge. Now, also the environment, if you're having any movement, okay? So you're out in a harsh environment, there's a stamping die, there's, forklifts coming by, there's just lots of stuff. That's going to be a challenge for these systems here and these systems here. They don't like things moving, okay? If things need to be locked down. If the part's rocking on the table, if the whole building is shaking, you're going to have problems with accuracy. There's just no way around it. These systems are much more forgiving. With the handhelds, the targets are on the part, so they're moving with the part, okay? So as you scan, theoretically, you can hold the part in your hand. And we've done measurements with some of these, literally doing that, and you don't see any drop in accuracy. And then the optical systems have what's called dynamic referencing, same concept. Again, if you want to learn a lot, go watch the videos, but parts can be actually moving around, and the camera system can be moving around, and you don't lose accuracy. And that's probing and scanning. So again, it really depends on what you're trying to do. But smaller stuff, they're all pretty good. As you get into bigger stuff, some of these are going to be better. And when you get into harsh environments where you've got noise, vibration, anything, the part's not fixtured up well, that's where some of these technologies are clearly going to be more accurate than others. So one of the most popular questions besides accuracy is cost. What do these systems cost? Well, there's a wide variety, and again, I'm sticking to commercial products here. Some of these you can buy are pretty affordable, and some can be very expensive, and there can be many steps in between. In general, the more accurate the system is, the higher the resolution, the more it costs, okay? But we'll talk in general terms because pricing varies from country, pricing changes, so I don't usually like to talk specific pricing in videos just because it's always changing, and again, there's lots of options. Structured light systems, getting something decent, you can start, in the 20s or 30s, thousands of dollars, but they quickly go up from there. You start adding turntables, you start adding a lot of lenses, you start adding higher megapixel, higher accuracy, you can get into the hundreds of thousands of dollars. So, you can start in maybe the 20s or 30s or 40s, but typically getting into a higher end commercial system, you could be 50 to 100K or more. Again, just depends. Are you adding photogrammetry, things like that. The optical systems, they tend to be more expensive too. Depending on options, you're not going to get into one of these commercial systems, for under 50 grand, and you can go up into 100, 150 grand when you add software and training and a shop floor stand and all that stuff. So, these systems definitely are on the higher end, but again, these are more accurate, especially with large parts, really geared towards metrology and high-end scanning. The handhelds, you have a really wide range here. You can get into some under $10,000 that are pretty decent, but you can get up into the 50, 60, 70K range for some ISO certified, high accuracy, really good systems. The nice thing with handhelds is there's lots of points in between. In the 20s and 30s, you can get into some nice systems. So again, it's just going to depend on the number of laser lines, the accuracy, the certifications, all those types of things. When you get into ARM systems, there's really not a lower end system. They have ARMs that don't have lasers, but most people are buying them with lasers. There used to be a little desktop version of these. I don't even know if they make it anymore. But most of these you're going to be, 50 to 100, 125 grand. Again, you can't look at just the scanner. You add the laser, you want the longer arm, you want the more accurate system, you want the interchangeable lasers, you need a heavy duty floor stand, you need software, you need training. You can be well on your way to 150K when all is said and done. So again, we're talking about the commercial market here. You can certainly buy sub $10,000 scanners, and if you're just having some fun or you're a hobbyist, they're fine. But when you get into especially metrology and you need ISO certification and you need these things measured to a standard, an industry standard, you're going to pay more for that because there's a lot more involved to be able to manufacture products to those standards and the repeatability, right? People need to know they can go out and use this thing and get those same results all the time. So price really varies depending on your budget, but all of these systems can get expensive, but all of them can be relatively affordable. Probably the most affordable is the handhelds and some of the structured light systems on the lower end, and certainly the ARMs and the optical, and even these can get very expensive just depending on what you need. All right, so that wraps up the video on comparing some of the different technologies out there in the 3D scanning and inspection market. And again, this wasn't specific to any maker, model, or brand. It's really about the kind of the different categories of technology. Now, if you want to learn more, People call us all the time and ask us, hey, what systems should I buy? And really, we really want to understand, what is it you're trying to do? What is your budget? What is your accuracy requirements? What size parts are you doing? How important is portability? Really want to spend some time and ask you a lot of questions to understand, what your needs are, and then we're going to try to pair the right technology for that. And unfortunately for some people, there's just not one right answer. Now, in a perfect world, you'd buy 2 or 3 or 5 systems, and then you could do everything. But most people don't, have an endless budget to do that, and the time it takes to learn all those systems. So it's figuring out what it is you do, what you do the most of, and then pairing it up and budget and all those things, and pairing it up with the right system that at least gets you, satisfy you to get most of what you want to get done. So if you want to learn more about any of these systems or have a conversation with us, you can call us at 877-845-2700, or you can email us at info@ems3d.com. And of course, check out our other videos, educate yourself, look at other people's videos, really learn the different systems, learn the pros and cons. It always helps to educate yourself. We like, it's always better to have an educated customer, or at least they have a general idea. Because then when we ask questions, they've got a general idea of what they're looking for. Maybe they've done a little bit of homework. They still have some questions. So feel free to reach out to us. We're happy to help you. And, if you're interested in buying a system, we'll help you, pick the right one based on your needs.